single population mean. Here is the null hypothesis that the population mean is equal to some specified value mu naught. Against one of the alternatives, that population mean is not equal to mu naught, or is less than mu naught, or is greater than mu naught. Now let's see that how do we perform one sample t-test in R. Here is the general syntax of the command, and these are the arguments of the function. Now data is the variable of the having sample values on which we want to conduct this test, and mu is the test value which is to be specified. There are other optional arguments which may be added to the command, like for specifying the type of the alternative hypothesis and the confidence level. If it's a two-sided test, then the test can be carried out by setting the alternative as two-sided, and if it's a left-tail test, then by setting the alternative as less, and for a right tail test by setting the alternative as greater. We also have an option of choosing the confidence level of our own choice. Now let's do a simple exercise by taking a sample of scores of 10 students to test the hypothesis that the average score of class is 60. Now let's go to the R console. Now here is a sample vector of scores of 10 students. Now this is the command where we have specified test value as 60, and by setting the alternative as two-sided and taking the confidence level as 95%. Let's run the command. Control R. Now this is the output that R returns. Now as we can see, here is our test statistic value, and this is the p-value, and here we have 95% confidence interval, and this is the sample mean. Now I could also run the command without using these arguments, alternative and confidence level, and as we can see, I would get the same result. Since by default this test is a two-sided test having 95% confidence interval. Now I would like to mention another thing here, that I can use the first few letters of these arguments. For example, like I can use alt instead of the whole word alternative, and I can use CONF instead of writing the whole confidence level. Still the command will work just fine, as we can see over here. Now let's do another example. By take a data of 12 car distances from our data set named cars to test the hypothesis that average distance traveled by cars is less than 25. Now this is an example of one-tail test. Now come back to the R console. Now here is the data set, cars. Let's see what type of data does it have. Now these are the this is the data of speed and distances traveled by 50 cars, as we can see here. Now I need to extract distances traveled by first 12 cars. Now this is the command to do that. So this is the distances were in the second column, and I need to extract only first 12 values. So let's run the command into data and just write data, and I have extracted 12 values of distances traveled by 12 cars. I could do the same by running this command by using the $ and name of the variable. Now let's run the test on this data, and by setting the test value as 25 and alternative as less, as it was a left tail test, and by setting the confidence level to 99%. Now let's run the command again. Now this is the output. Again, the value of the test statistic, the p-value, 99% confidence interval starting from -infinity to 24.299, and this is the sample value. Now here I would like to mention another thing, that I can store the outcome of the test as an object to some variable, let's say t here. Okay, this is the test, and the result, the outcome generated by the test, that I can store into as an object into some variable t. Now let's run the command. So if I can view the outcome which has been stored in the variable t, let's type t, and I can view the outcome whenever I want. Now to view the attributes of this outcome, I will use the command attributes within parentheses the name of the object. So let's run the command. Now these are the names of the attributes of the outcome, the above outcome, and which any of the attributes, I can extract any of the attributes whenever I want. Like this is the object name, $sign, and the name of the attribute, like $p value. I can view the p value of the test. Now this is the p value, and again I can extract the confidence interval of this outcome by running this command. Now this is the confidence interval, and so on, and these attributes, these it can be used for the further analysis. Now that's all for this video, and thank you for watching the video.